many people here interested in rivers, and if you will see my slides now, you will think that me and Camila and I, we've been talking all night long about this, and we haven't. So I'm going to present this study, which actually is an ongoing study that's been going on for a long time with Rob Brumfield at the LSU. Sancho Caramull is collaborating in the final part of this talk, and I have students also helping on this. So we now know that Amazonian rivers are important geographical barriers. Wallace returned from the Amazon in 1852 and gave a talk about the monkeys of the Amazon. Basically, what he's shown at the time, and we know now, that many species of birds and mammals had their boundaries defined by rivers. So I think it's now a fair question to ask, what have we actually done in the last 163 years in relation to these observations? Have we advanced or not? So actually, I divided our time, and I think we took about 100 years, more than 100 years, to basically describe the taxa, describe distribution patterns, and we're still doing so. Then we took another 20 years to deal with the great Jürgen Hafer and his places of refuge hypothesis that unfortunately kept us in some dichotomic discussions about the timing and Pleistocene, pre-Pleistocene. But I think we're now at the end of another era, which is the molecular data and the Beccarian paradigm, which is, I think, was first started by Angelo Caprarella's great work on the Naka River. So basically, during these almost 20 years, we've been trying to find common diversification patterns and trying to fit the history of the landscape with our data. So we've seen a lot of ericladograms, a lot of phylogenies, and I think the pinnacle of this approach was a very good paper of Camille and collaborators. But basically, we're trying to fit to model the history of the Amazon based on one phylogeny, one particular phylogeny. So I think it's fair now to start asking whether areas of endemism are actually regions of common diversification. But today I will talk about whether rivers that divide these areas are the promoters of avian diversity as primary barriers. So today I'll be talking about this first, and then I will ask whether any signs of common diversification processes in pairs of co-distributed taxa, and then to what extent Amazonian rivers are meaningful barriers for birds. So we know, well, this was later. So here we have the Rio Negro, the Rio Branco. Camila made all paved the way for us. So as you know, as Camila said, if you are in Manaus and you look to the other side of the river, there are about 78 pairs of taxa that replace one another. And this comes from like parrots, different species of barbets, nunbirds, tawny terns, flycatchers, etc. So here we have a tree of all those, about 330 species of birds that are occur in Manaus, in the territorial forests of Manaus, and in red you can see those lineages that do have phenotypic differentiation across the Rio Negro. So this study was based on 62 of those avian lineages for which I had samples from both sides of the Rio Negro and the Rio Branco, we'll see in a minute. So basically I took this comparative community-wide approach using samples from some meaningful riverine barriers. The first approach was to basically simply estimate divergence times in pairs of taxa separated by the lower Rio Negro. And what I found was kind of interesting. So basically, each one of these dots here is one divergence times among those 62 pairs of taxa. And what we can identify here is that the separation of taxa currently bounded by the lower Rio Negro has occurred in a rather constant fashion since the Pliocene. And if we fit any single current event, it will be very difficult to explain the whole diversification processes with just a single event. And this comes into terms with some ideas that Ruhl has put forward, such as a careful analysis suggests that the origin of extended tropical diversity cannot be attributed to the action of one or a few events during key intervals. But actually, that would be an unfair comparison, because we know, I myself have been working on this area for many years, and we know that whereas we have 78 different pairs of taxa that replace one another across the lower Rio Negro, if you go upriver, only 19 of those continue to be replaced. So actually you have three different distribution patterns. We have birds that actually are divided by the entire length of the Rio Negro. We have other birds that are divided by the lower Rio Negro and then the Rio Branco. And other birds that are divided by the lower Rio Negro, but they replace one another with the Branco Negro fluid. So I tested, to ask whether there are any signs of diversification, of common diversification, I divided those. I picked 27 pairs of taxa that are divided across the Rio Branco and 17 pairs of taxa that are divided across the Rio Negro. So I took an approximate Bayesian computation approach, such as empirical, which takes into consideration the stochasticity of the coalescence and incorporates interspecific variation in simulations. And what I found is actually there are some reasonable support for common diversification across those pairs on the Rio Negro, whereas there is no support at all for common diversification for those 27 pairs across the Rio Branco. So here we have the timing, Pleistocene, Miocene. So you can see there's no support for pairs across the Rio Branco, but there is support for a decent number of pairs across the Rio Branco, the Rio Negro. So basically, this suggests that rivers might have been a primary barrier for about 12 pairs of taxa. So if we think that there are 78 pairs here, and the river could explain, we saw that could explain 4 cases in Camille's work, so actually it could explain a bit more, 12. That's a pretty decent explanation. However, we're trying to explain 78 pairs. So the first conclusion here is that rivers, very distinct, such as the Branco or the Negro, could be important biogeographical barriers, and that, what I just said, that the Rio Negro is possibly an important barrier for a few of those taxa. So, but I think that we are really at the end, and I think the inclusion with the results from Camille are showing that if we have to include new data on our parameters, so I think we have failed trying to find common patterns when we pick the entire fauna. So I think we need to start gathering new data on effective population sizes, on ecology, on functional traits, how these will affect our genetic structure, dispersal, gene flow, migration, and things like that. So I'm going to show you now our second part of the talk about dispersal. What was our take on the terms? So we've been doing some experimental, we're testing the dispersal ability of Amazonian birds doing experiments. This is nothing new. It was a very, very cool experiment done in Panama a few years ago with more collaborators. So basically we go to the forest, we catch the birds, we go to the middle of the river, we'll put the birds in little cages, we open them, and we see what happens. So we do have some protocols to protect the safety of the birds, so we keep the handling to a minimum. We have 4 different distances for 100, 200, 300, and 400 meters from the shore. We don't release birds when it's very windy, etc. And then we measure 4 variables. One is the success of failure to reach the other shore. We measure the reluctance to fly, which is the time that a bird will take before actually making it to the other side. And then we have the distances flown and the speed, because we measure the time as well. So you want to know what we found? Well, we have released now about 500 individuals of 83 different species of about 21 bird families. And what we found is a reasonable amount of birds, so 35% of them fail in crossing a single gap of 100 meters. And if you want to know what it looks like, the fader, this is how it goes. And we go with the speedboat, we catch it, and we release it, and everybody's happy after that. So we have some species that are very good dispersers, they never fail. We have some species that are very bad dispersers and always fail. And we have some species that have some mixed results. So if we look at which families are actually succeeding in these experiments, we see that there are at least 3 different families that show up for being pretty bad. And these are the Thalnophilidae, the Troglodytidae, the wrens, and the Rhynchosynclidae, some total flycatchers. So that puts us, why are they failing? So we went back to wing morphology, and obviously you see different shapes. So we've been taking a bunch of measurements from the birds and from the wings, but now I want to take your attention to the KIP index. KIP index is a simple measurement that can be taken on specimens, which measures the length of the primaries as opposed to the length of the secondaries. And this gives you an idea whether a wing is rounded or is rounded. this has been explained, keep indices. But if we zoom onto this, the rest of us, you'll see that two of the families have particularly low keep indices, which are the phenonophilidae and the rank, which were the bad dispersers. Here we've been playing around with a few models, trying to see the probability of success in terms of keep index, and we can explain a little bit about, 17% of the variance there. And so basically this is, I think it's a powerful graph. So if you think of a keep index of 30, you go, and that's the chance of actually succeeding one of these experiments. But there's a lot of noise in there, of course. So I think we'll need to do more ecology into this, more ecology. We know that antbirds are very low dispersal abilities. They're bad dispersed among fragments, across roads. They were among the worst dispersers in the Panama experiments. But the idea here is to try to see whether we can explain diversification by including a new variable, which is dispersal ability. So from the tree I showed you before, 78 taxa that replace across the Rio Negro, 17 of those are antbirds. Like I said, it's a decent amount. So here I'm just making some comparisons of some of the pairs that had very limited dispersal abilities, which means 100% of failures. Those are replaced by two across the Rio Branco. So we have the Hypognemis flavescens and Cantator, which have a 6% divergence across this river. Another pair of populations, two different subspecies of Corallo wren, they have a 12%, and those were among the bad dispersers. And then if we compare some of the good dispersers, we have about, for which we had 100% of success within the antbirds. There is no geographic structure across this particular river. So I think that my second conclusion here is that avian functional traits, and in this case the dispersal ability, can be measured empirically and experimentally, and they can help us explain genetic structuring in Amazonian birds. And I think the take-home message here is that vicariance is a powerful explanation for current patterns, but we've been tricked in the past, very recently. So I think that we should use Amazonian areas of endemism because they are very, very useful, null hypotheses, but we have to include new things for our explanations. And I would like to thank the funding agencies and some people, and a lot of people have been helping me in the field. And thank you so much. And there's some time for questions.
One question.